So this was a test related to properties of a wave, sound, light, and electromagnetic spectrum, which is block 3. The first question, the diagram shows a wave before it reflects from a barrier. Which label of a section represent the wavefront? So what A is representing? A is representing a direction of the wave. In which direction the wave is moving. What B is representing? The distance between the two successive crests, that is called a wavelength. So B is representing a wavelength or length of a wave. What C is representing? C is representing a wavefront. Wavefront means the line which is representing the identical point of different waves. And what about D? D is the surface. So the correct answer, C, which is representing a wavefront. Then a vibrating object produces a ripple. The object completes 20 vibrations in every second. The spacing of a ripple from one crest to another is 3 centimeters. So wavelength is given. What is the speed of the wave? So how to find the speed? Speed is frequency multiplied by wavelength. So number of vibration every second is frequency. So frequency is 20. And the wavelength distance from one crest to another is 3 centimeters. So lambda is 3 centimeters. If wavelength is in centimeter and frequency is there, when we multiply, we'll get speed in centimeter per second. So frequency is 20 and the wavelength is 3. So 20 multiplied by 3, it is 60 centimeter per second. So C will be the right answer. A narrow beam of a light is traveling through a transparent liquid. It meets the surface as shown. The angle of the incidence is 40. The refractive index is 1.5. What is the angle of refraction? It is moving from glass, liquid to air, from denser medium to rarer medium. It will bend away from the normal and we need angle of refraction. So when from denser to rarer, it is sine angle R over sine angle I. The refractive index is 1.5. Sine angle R, we don't know. And sine angle I, the angle of incidence is 40. This is 40, it will be multiplied there. So 1.5, it is divided, other side multiplied. 1.5 into sine 40 is equals to sine R. And then 1.5 is the refractive index. And the angle of incidence is equals to 40 degrees. So we have the angle of incidence, the refractive index is 1.5 multiplied by sine, and the angle is 40. But always remember, whenever you're solving a question, your angle should be in degrees. So because first it was in radian, so I have to do it again. 1.5 multiplied by sine 40. So that is 0.96. So that is 0.96 is equals to sine R. But we need R here. We need R. So if we need R, sine will move other side. So this will become sine inverse 0.96. That's equal to R. So shift like inverse, sine inverse. The answer that is equal to 74.6. So the angle of refraction should be 74.61. So we'll check which option matches with 74.61. So 74.61, it is closer, 75 is there. So D will be the right answer. Then in question 4, which diagram correctly represent ray of a light passing through a converging lens? Remember, when a ray is passing through a center, it will pass straight without changing a direction. So this ray is passing through a center, it should pass straight. This ray is passing through the center, it should pass straight. So A is the right answer. Why not B? Why B is incorrect? Because if it is parallel to the principal axis, so it should pass through the focus, like it should converge at one point. That's why B is wrong. Why C is wrong? C is totally wrong because in the air, they change the light is crossing. It should pass through the lens. And another thing, when it is passing through the lens, like passing from the focus, it should go parallel. That is a second mistake. So when the ray of a light is passing through the focus, it should go parallel. So that is C is also wrong. What about D? D, the light should change the direction. It should converge at one point because it is not parallel to, if it is passing through the center of the lens, that is the only case when the light can pass straight. But it is not the center of the lens, and there should be a refraction in terms of change in direction as well. But D, there is no change in direction. So the correct answer is A. Question 5, what is the speed of light, X-ray and vacuum and in air? So approximate speed, there is a very small change in speed, negligible change in speed is there. So it is 3 into 10 to the power 8 in vacuum. And there is also approximately same speed in air. So D is the right answer. For all the electromagnetic radiation in vacuum, in air, there is a change, but that is negligible. So we say that that is same as speed in vacuum. A sound wave passes a point. The pressure at point increase and decrease 300 times every second. So if the pressure is increasing 300 times every second, that is giving us an idea about the frequency. So the frequency is 300 hertz. And the audible range, the normal human ear, it can from 20 hertz to 20,000 hertz. That is the frequency, the audible range for a normal human ear. So this is within the audible range because 300, we can hear 300. And what kind of waves are sound? Sound waves are longitudinal. So it is a longitudinal wave and it is within the audible range. Then the waves are passing from deep water to shallow water. So will be a change in speed, and whenever there is a change in from moving from deep water to shallow water, in a deep water, the waves are moving faster and the wavelength lambda is longer. But in a shallow water, the wave will slow down and the lambda, the wavelength will decrease. So what happened to speed and the frequency of a wave as it moves in a shallow region? So what happened to frequency of a wave does not change. Frequency is a ratio between speed and wavelength. The ratio between speed and wavelength in a deep region will always be same as in a shallow region. So the frequency does not change. Frequency remain constant, but the speed moving from deep water to shallow water decreases. So for 7A should be the right answer, that the speed decreases where frequency remain unchanged. So frequency never changes. Remember this. Only what happened, the frequency and the wavelength will change. Moving from deep to shallow, the speed and the wavelength will decrease. Then all electromagnetic radiations are transverse. So this is a transverse, radio is a transverse, water is a transverse, and the only longitudinal is sound waves are longitudinal. So that's why B is the right answer. Light refract from a liquid into an air. The refractive index of a liquid is 1.4. We have to calculate this angle of incidence. What about angle of refraction? This is the angle of a light which is emerging out. with the surface. So angle of refraction is angle between the normal. So this will be 90 minus 32. That will give us the angle of refraction. So that is equals to 58. So angle of refraction is 58. Whenever light is moving from denser to rarer medium, the formula refractive index is equals to sine R over sine I. So refractive index is 1.4. Sine R is equals to 58 and sine I we don't know. Now we'll use so the formula refractive index equals sine R over sine I. Refractive index was given in the question 1.4. Angle of refraction from the figure we work out that was 58, and angle of incidence we don't know. We cross multiply, sine I will move there and 1.4 there move individual. So it will be sine 58 divided by 1.4. So always whenever you're using a scientific calculator, the mod should be in degrees. So we have sine 58, that is 0.8480 divided by 1.4, that is equals to 0.60. So it means sine I is equals to 0.605, but we need I here, so I equals the angle of incidence, it's equal to sine inverse 0.605. So we'll press shift, sine inverse of our answer, that will be 37.28. So the angle of the incidence, the angle in the liquid is 37.28. So we'll check the options. So 37.28, we have option B as a right answer. When an object is placed in front of a plane mirror, the student views the image of the object in the mirror. Where does she sees the image? So always remember the object distance should be equal to image distance. So if object is, like example, 2 centimeter from the mirror, for a plane mirror, the image should also be same distance. So, and both should be in line with each other, perpendicular to the surface. So that's why option D is the right answer. In question 11, the light has a speed of 1.24 into 10 to the power 8 meter per second. What is the refractive index? When we have the speed, the formula for refractive index, speed of light in air, which is 3 into 10 to the power 8 divided by speed of light in medium, which is 1.24 into 10 to the power 8. So simple, 10 power 8 will cancel with 10 power 8. So what we have to do, we just have to divide 3 divided by 1.24. So that is equals to 2.419. The answer 2.419, which is equivalent to 2.42. So question 11, C is the right answer. Question 12, which statement describe a monochromatic light? Light which is having a single frequency or a wavelength, we call that as a monochrome. Mono means one, chrome means color. But it does not mean one color light. Even like we have a red color may have a different frequency, different shades of red, so may have different frequencies. So scientific definition, light which is having a single frequency or single wavelength is refers to monochromatic. Question 13, both amplitude and a frequency of a sound decreases. So amplitude affects the loudness, and frequency affects the pitch. So what will happen? The sound will be, because if amplitude is decreased, so sound will be quieter, and if the frequency is decreased, so it will have a lower pitch. So D will be the right answer. In question 14, sound wave is traveling through water. What is the possible speed of the wave? So remember, like sound travel fastest in solid than liquid, and in liquid travel faster than gas. Approximate speed is 5,000 in solid, approximate speed is 1,500 in liquid, and approximate speed in gas 300 or 330, 340 you can write, as it vary with temperature. What is the possible speed of wave that is in water? So that is 1,500. This is in solid, this is one is in air or a gas. We have to learn the speeds in solid, liquid, and gas. In a shallow tank, a water waves move forward through passes through a narrow gap. So when the wave is passing through a narrow gap, we will have a maximum diffraction. The wave will spread out. So it cannot be A, it cannot be B. C also is not correct. So it is actually D, because when it passes through a gap, it spread out, and that's why D is the right answer. If it's a gap is a wider gap, then only slightly it will bend if it is a wider gap. But if it's a narrow gap, maximum diffraction, the wave will spread out. Light passes along an optical fiber. What happened to a light within the optical fiber? So like optical fiber or light pipes, transparent material. So how the light is able to travel from one place to another through optical fiber? When the light strikes, it undergo total internal reflection. Like here, the angle of incidence is more than critical. If it was less than critical, it will go out. Equal to critical, it will travel at 90. But because it is more than critical, so all the points, the light will undergo total internal reflection. So D is the right answer. In question 17, the point label F is the focus. A parallel light ray. So whenever we have a parallel light ray, from where it will pass through, it will always pass through focus. So this is incorrect. This is correct, because when parallel light ray is passing through focus, this is also incorrect. This is also incorrect. So remember, if a light ray is parallel to the principal axis, it will pass through focus. If it is passing through the focus, it will go parallel. And if it is passing straight through a lens, like through the optical center, it will pass straight without changing a direction. In question 18, which statement about the sound wave is correct? So sound required a medium to travel. Sound cannot travel through vacuum. So they are able to travel through vacuum. That is not correct. They are able to travel through solid. That is true, because sound required a medium, solid, liquid, or gas. They are able to pass. Sound waves are not transverse, they are longitudinal, and they travel at the same speed in all substance. That is wrong. In solid, the sound travel faster compared to liquid, and liquid it is faster than a gas. In question 19, which statement about the ultrasound is correct? Ultrasound, because the audible range is the normal human ear, that is 20 hertz to 20,000 hertz. So any sound which is having a frequency more than 20,000, we call that as ultrasound. Less than, that is infrasound. So how ultrasounds are? It produced by rapid vibe, because if something is vibrating more, it will produce ultrasound sound with a higher frequency. So A is the right answer. It is uncomfortable to human ear. Even our ear is not able to detect these high vibrations. So it is not, we are not able to detect. So that's not uncomfortable. Its frequency must be greater than 300,000. No, its frequency should be greater than 20 kilohertz, we can also say, or 20,000 hertz. It travels faster. No, it travels with the same speed, like normal sound or ultrasound. They have the same speed. The only difference is the number of vibration. So A is the right answer, that ultrasound is produced by high vibration or a rapid vibration of the source. A ray of a light, a red light is in air, enter a semicircular glass block, which diagram shows a partial reflection and refraction. So when it is passing, the angle for reflection to occur, the angle of incidence must be equal to angle of reflection. So here, this is wrong because angle of incidence is not equal to. This one is also wrong. Angle of incidence not. C and D, angle of incidence and angle of reflection are same. But when it is moving from glass to air, when we draw the normal, moving from glass to air because the speed increase. So as the speed increase, this should bend away from the normal. Here, why it is wrong? Because it is bending toward the normal. But moving from glass to air, it should bend away from the normal. So D is the right answer for this. Question 21, a white light entered a prism forming a spectrum. So violet bends the most and red bends the least. So A and B are totally wrong because it does not show any change in direction within the prism. C and D can be an answer, but why D cannot be? Because here violet bends least and red bends most. It should be opposite. Violet bends the most and red bends the least. In question 22, the sound from a ship is reflected from a cliff and echo is heard in 4 seconds. The speed of a sound is 320. How far is the cliff? Whenever there's an echo, speed is 2d divided by t. Sound travel and then return back. So that's why it's 2d. We need the distance. So it will be speed multiplied by time divided by 2 will be equal to distance. So speed is 320. The time is 4. And divided by 2. So this we simplify 320 multiplied by 2. That's equal to 640. So B will be the right answer. So whenever there is a reflection or echo, you will always use speed is 2d divided by t. A water wave on a pond passing through a region where it traveled more slower. Then it returned to a region. So example, if we have a water tank, a water wave is fast, where the wave is traveling more slower, then it returned to the original region. So first we have example, first we have a deep region. As I mentioned, a water wave on a pond passing into a region where it travel more slower. So if you're traveling more slower, so first it is a deep region, then it should be shallow. Why? Because they mentioned a water wave on a pond is passing into a region where it travels slower. So if it travels slower, so one side we have a deep region, then we have a shallow region, and then we'll have and they mention it then return to a region where it was traveling with the original speed. So center, we have a shallow region. If we are looking the wave sideways, because in a deep region, the wave travels faster, but in a shallow, the wavelength decreases, so it will slow down, and then it enter a deep region, so it will travel faster. So which one matches with, which one is the correct way? So means this was in a deep, then shallow, and then deep again. So that's why, because the wavelength in a shallow region, the wavelength decreases. So, and they already mentioned as it slow down, the wavelength should decrease. So A should be the right answer. What is meant by amplitude? Amplitude is basically a distance from mean position to extreme position. When we measure a distance from mean position to extreme position, we call that distance as amplitude. So maximum distance of a particle move from its equilibrium position. So B is the right answer. Like the maximum displacement which it moves, equilibrium position is the center position. So what is the maximum displacement from its equilibrium position? We simply call that as amplitude. Then a ray of a light is passing through a glass block in which angles are which angle is the angle of refraction. So moving from air to, we always measure the angle from incident, angle from the normal. So according to this part, angle of incidence is B and angle of refraction is D. And one more thing, it depends on how the light is moving. Like example, if a light is moving from air to glass, say this is the angle of incidence and this is the angle of refraction. So the formula for refractive index moving from air to glass is sine angle I over sine angle R. But if it is moving from glass to air, like this is angle of incidence and this one is angle of refraction. So moving from glass to air, the refractive index is sine R over sine I, opposite. So you have to check in the question that which medium it is traveling, glass to air or air to glass. So here D is the right answer, which is representing the angle of refraction. Then a ray of a light is deviated. The angle of a deviation, like how much it changes its direction from the original, that's called the angle of a deviation. So if we increase the frequency, like example, if we use higher frequency, then its deviation is more. Like if I use a blue color, blue is having a higher frequency, so it will bend more. And if we use the red color, it will bend least. So when we compare the angles here, so for red, the angle of deviation is small. For blue, the angle of deviation is more. So it means the angle of deviation increases if we increase the frequency. So that's why for this one, D is the right answer as well. So when we increase the frequency, the deviation, angle of deviation will also increase. So D is the one which is correct. In question 1, figure 6.1 shows a crest. On a figure, draw the 3 more crests. So whenever a wave is passing near the gap or the edge, it will change its direction. So it will bend. And keep one thing in mind, what distance is here, the wavelength, same distance you should make for others. State the name of the process that occurs when the wave passes through a gap near the edges, what we call that as diffraction. Then figure shows a crest of another wave moving from deep water to shallow water. On the figure, draw an arrow to show the direction of the wave. How to show the direction of the wave? These are the wave front. Remember, the direction of the wave is always 90 degree. So if these are the wave front, I can draw a direction 90 degree to the wave front is known as direction of the wave. And the next part, state the name of a process that occurs as a wave passes into a shallow. So when it moves from deep to shallow, the speed decreases, speed changes. It changes the direction as well. So what we call that as refraction of the wave. Refraction means property of a wave to change speed or direction when it travels from one medium to another. In deep, it is traveling fast, where in shallow, it is traveling slower. Then complete a table, state whether each of the property increase, decrease, or remain same. So wavelength is the distance between two successive crests. You can clearly see in a deep water it is longer, but in a shallow water it is shorter. So the wavelength decreases. Speed also, moving from deep to shallow, speed decrease, but the frequency remain constant or stays same. Here it decreases and speed also decreases. Figure 7.1 show on a figure, draw two rays to locate the position of object. So how to locate the position of object? First, because the idea is that if this is an image, so there will be parallel light ray. There will be a light ray from the object which is passing through the center of the lens and reach. And there will be another light ray which will be parallel to the principal axis, which will pass through the focus. So when we locate the position of object, so object will be here, because if there's a parallel light ray, it will pass through focus, and one through the center of the lens will pass straight. So the point where the two light rays intersect, that is the position of actually the object in this example. So two light rays from object passes through a lens and converge at one point. And ring, the distance which is equal to focal length. So focal length is a distance from center of the lens to the point where the light rays converge. So from C to B, or we can also say from A to. So from C to B, or we can also say from A to C. This distance is a focal length, or we can also say this is also focal length. Then on figure, we have to draw the path for a green. So green light will bend more. So this will be the part taken by the green light. And here we have to show part taken by red light. Draw path for the red light. So red will bend the least. So it will bend least. So this will be the part taken by the red light. So if we know the